Kia ora, Year 12. This is a great question from Jolyon from the March 2016 paper. It's a trig substitution question, and I think that it would have been fine even if they hadn't given you the first show that part, but you just have to work quite slowly through the trig substitution. Now, it's not a trig substitution where we're going to use the inverse tan thing, so it's not one like this. It's a little bit different. It's actually easier. We're going to use a straight up trig substitution given to us here, that x is equal to √3 tan theta. We are, however, going to go over the tan inverse ones in class tomorrow. Okay, it's one of the last things that we look at. So we're given an integral and we're told to use this substitution and change this over into that form. So you can see in here that obviously my limits of integration have changed and everything is now in terms of theta. So we'll start with this. So let x equal √3 tan theta. Remember, we need to replace this and we need to replace this as well as the limits. So dx by d theta is going to equal √3 sec squared theta. Rearranging that, because I want to sub out the dx, I get √3 sec squared theta times d theta. So that's the first thing that we're going to change over. And now I need to have 3 plus x squared, all squared. So x squared is equal to 3 tan squared theta. 3 plus x squared is equal to 3 times 1 plus tan squared theta. So let's just look at how we can simplify that. Remember, back in AS we had sine squared plus cos squared equals 1 was the only identity that we knew, and we can switch that around. So here, if we divide through everything by cosine, we get tan squared theta plus 1 is equal to sec squared theta. Okay, so we've got that. We're going to use that fact in here. So we've got 3 sec squared theta for 3 plus x squared. So it's time to start transferring everything over into that integral. So the integral we started with went from 1 to 0 of 9 over 3 plus x squared dx. Sorry, the last thing I've got to do, of course, is fix up my limits. So we've got x is equal to √3 tan theta. So we need to find theta as a function of x. So x over √3 is equal to tan theta, giving us theta is equal to tan inverse, so the angle whose tan is x over √3. So doing a little table, here's my x value and here's my theta value. So tan inverse of 1 over √3 and tan inverse of 0, which is just 0, right? Remember at the very start of the year, I'm pretty sure I told you we'd use these special triangles all the time. So there we go. What's tan inverse of 1 over √3? Well, it's pi on 6. So finally now we're ready to change over the limits and all of this. So my limits are going to be pi on 6 to 0, and then I've got 9 over, so 3 plus x squared here needs to be squared, so 9 over 3 sec squared theta squared, and then dx from up here is equal to √3 sec squared theta d theta. So we're nearly finished with those first 3 marks. I'll just shrink my screen a wee bit. I might just neatly put a marker in here. So remember, in the exam they don't like you working like I'm doing here, so please just work down the page tomorrow. Don't do this weird stuff. Okay, too bad. Okay, so what have I got? Well, I've got, we'll take out the √3. We've got the integral from pi on 6 to 0, and we've got 9 over 9 sec to the power of 4 theta, or sec theta to the power of 4 times sec squared theta, d theta, up to some easy stuff now. So √3 between pi on 6 and 0, 1 over sec squared theta, d theta, which finally gives me what we want, √3 times this integral. So actually, for 3 marks, that's quite a bit of work, but the next 4 marks is pretty easy. You've just got to be a bit careful. Find the exact value of I. So we're down to what should feel like a really easy integral. We know that we're going to use our double angle formula, or at least that's how I did it. So we know that cos of 2 theta is equal to 2 cos squared theta minus 1 cos of 2 theta plus 1 divided by 2 is equal to cos squared theta. So over here, we've got root 3 over 2, then the integral between pi on 6 and 0 of cos of 2 theta. What have I got now? Where am I up to? Cos of 2 theta plus 1 d theta. So I don't get why they did the marks how they did them, because this feels fine, right? So we've got half of sine of 2 theta plus theta evaluated at these limits. So we've just got to watch out for positives and negatives now. So it's root 3 on 2 times 1/2 of sine of pi on 3 plus pi on 6 minus sine of 0 is 0, so 0 plus 0, giving me a final answer of root 3 on 4 times 1/2 plus, what have I done wrong here? Something weird's happened. Oh no, that's right. Hang on. That's not right. It's not 1/2. It's root 3 on 2. That's better. And then plus root 3 on 12 pi, which gives me a final answer in exact values of 3/8 plus root 3 on 12 pi. Okay, so that's what we get for the integral, and that, if you look at the schedule, is the right answer. So lots of things in there. If you haven't watched this one by tomorrow morning, I'm probably going to make you watch it in class or go over it. Just be confident with your with this bit here. I think this is one place that people will probably go wrong, is with changing the limits over. But remember that it's a show that question, so they go on and on in the examiner's report that you must show your steps of working. Okay, so this bit here is the easy bit. This bit here is the bit that's hard to get every little step right.